Example 4 is a type 1 type of partial fraction, but we're going to do this one using the alternate method. And that alternate method is setting the factors equal to 0. And we do this by selecting x values that will give us factors that equal to 0. So here we split up in here. Okay, we split up the partial fraction, then we cross multiply to get the numerator, and we make the numerator equal to x minus 2. Okay, so at this point, what we could do is expand and group our like terms and equate coefficients to get our system of equations. This is our alternate method where we're going to generate factors of 0. And we're going to do that by, first of all, substituting x equals negative 2 into this expression. And then we're going to set up a second equation where x equals 0. That allows us to solve for the a and b coefficients. So we're going to substitute x equals negative 2. When we do that, we end up with negative 2 plus 2. That generates a 0 factor here. And that means that we end up with a times 0, and that gets rid of that whole a part. And then plus b times, well, we set x is negative 2, so we're going to plug negative 2 in there. And that's equal to negative 2 here, so negative 2 minus 2. So I've plugged into this original equation here, I substituted x is negative 2. That generates a 0 factor. And what that does is eliminates the a, and now I just have the b to solve for. I'm just going to color code this so that I keep that b as red. So I'm just going to solve for that b, and I get negative 2b is equal to negative 4. We get b equals 2. Okay, so that's going to solve for the b. Now, secondly, we can solve for the a. What we're going to do is substitute x is 0 this time. And when we substitute x is 0, I'm going to end up with 0 plus 2 plus b times 0 when we substitute for x. And again, in this case here, now this portion generates a 0 factor, which is equal to 0. So that part disappears. And then we end up with 0 minus 2 on the right-hand side of the equation. So now we've generated a 0 factor that's going to be equal to 0. We can solve for the a because we end up with 2a. 2a is equal to negative 2. And then solving for a, we end up with a is equal to negative 1. Okay, so this is an alternative to setting up a system of equations and solving for a and b by equating coefficients. This is different. We are substituting for x to make the factor 0 to get a 0 multiplier, and that allows me to get rid of the a value for one equation and the b value for the other equation. Okay, and then lets me solve for a and b this way. So this is an alternate method. It's really important that you get one strategy down. The system of equations tends to be a little bit more flexible, but this one here, specifically for these type 1s, are a real quick, easy way to solve for a and b. Okay, so once I solve for a and b, I'm going to integrate this. So I'm going to split this up into partial fraction integrals. So it's going to be negative 1 for a all over x plus it's going to be b over x minus 2. So our b value we solve to be equal to 2. And that's going to be over x plus 2 times dx. Integrating this, we end up with negative log x plus, and I'm going to take the 2 out, it's going to be log x plus 2, and then our plus c. Okay, so there's our integral. We split it up using that partial fractions. I'm just going to combine these logs. So I'm going to end up with log. The positive goes in the numerator as positive power, so that 2 becomes a positive squared, power 2, and then the x goes in the denominator because that negative is divide, and we end up combining that, and then we have our plus c. Straighten that out here. And so we end up with log of that expression plus c.